Let's assume our URL shortener is deployed now. Two users create links at the same time. Two API calls generate the same shortcode ABC123. Both API calls quickly check is this code free. Both see yes. So both insert. Now the database has two rows with the same shortcode. So when someone's open slash ABC123, where should we send them? This is a kind of bug that looks small in code, but it destroys trust in the data. And the fix should not be please remember to validate in every app file. The database itself should say no, this row is not allowed. That is what constraints are for. At high level, app validation is good. We should check inputs before we write. But it is not enough by itself because real systems do not have only one clean path into the database. There is the API server, there is a background worker, there is a migration, there is an admin script, there is someone of import job that someone runs at 1 a.m. because production is on fire. So if the rule lives only in app code, every path has to remember it. If the rule lives in the database, every path has to obey it. That is the difference. Constraints are the shared boundary. They are not SQL fancy. They are how the database protects the truth when the rest of the systems gets messy. The simplest constraint is not null. It means this column must have a value. For a short link, short code can't be missing. Long URL cannot be missing. User ID probably cannot be missing if every link belongs to a user. Without that rule, you can't insert a row that the app can't even use. Then default is the friendly version. It says if the app does not provide a value, use this one. For example, created at can default to the current timestamp. So not null says this fact is required. Default says and if it is predictable, the database can fill it. Small rules only, but they remove a lot of boring bugs. Now, we need two different ideas identity and uniqueness. A primary key is the row's identity. In short links table, maybe ID is the primary key. It is not null and it uniquely identifies one row. So, even if two links point to the same long URL, they still have different row IDs. But shortcode has a different rule. It is not the internal identity of the row, but it must still be unique because slash ABC123 can only mean one thing. That is a unique constraint. And this is where it becomes practical. Remember, the two API calls from the start, both can raise, both can think ABC123 is free. But when the second API call insert reaches the database, the unique constraint rejects it. The app can catch that error and generate another code. So the databases becomes the final referee, not because we distrust the app, because concurrent systems need one place where the truth is decided. Next is the foreign key. In the last video, we used user ID to connect short links back to users. But if we do not declare a rule, user ID is just a number. The database does not magically know it where to point to a real user. So a foreign key says this value must exist in that other table. So short links dot user ID must match with some users dot ID. Click events dot shortlink ID must match some shortlinks dot ID. This prevents orphan rows, like a click event for a link that does not exist, or a short link owned by a user that was never created. And one important correction foreign keys are not just for joins. Joins read relationships, foreign keys protect relationships, different jobs. Then we have check. A check constraint is basically a Boolean rule for a row. For example, If we store a click count, it should not be negative. Or maybe short code length should be at least 4. Or expires add should be after created add. If the row violates the expression, the database rejects it. I would not treat check as a full business rule engine. A lot of business logic still belongs in the application. But for simple truths about a row, it is very useful. The rule sits next to data itself. That is why it works. Now, foreign keys create one more question. What happens when the parent row is deleted? Let's say a short link has 10,000 click events. If we delete the short link, what should happen to those clicks? There is no universally correct answer. One option is restrict, do not allow the delete while child rows exist. Another option is cascade, delete the link and automatically delete its click events as well. Another option is to keep analytics history and mark the link as deleted instead of physically removing it. This is why I don't like explaining on delete cascade like it is just syntax. It is a product policy. In some applications, cascading is exactly right. In some other, it silently deletes the historical data you needed. So, before choosing the SQL, ask what should remain true after this delete. That question matters more than the keyword. So, constraints are not decorations after schema design. They are the schema becoming enforceable. Not null says the fact is required. Default fills predictable values. Primary key gives each row identity. Unique protects business uniqueness like a short code. Foreign key protects relationships. Check protects simple row level truths. And delete rules decide what should happen to the related data. The bigger idea is this: app validation catches mistakes early. Database constraints catch mistakes everywhere. In the next video, we use the relationships we designed and protected. And we finally ask questions across tables properly. Joins.